Hey, and what's up, guys? Today we're going to be attempting to solve the 2023 HSC Physics exam. So we're going to be just doing the multiple choice section, and we want to see how much we can get right by using just the guessing methodology. As I call it, educational and situational based guessing, situational awareness based guessing. Okay, so let's get into it. We're allowed 35 minutes, but the aim is to do it in 8. And I want to walk you through my thought process, and I always ace these exams, and I'll run through the solutions in the end so you can double check how much we got. Alrighty. So the first question: 3 darts are thrown by the player aiming at the bullseye center. If the objective of this game was to hit the bullseye, which statement about the 3 is correct? The throws are precise but not accurate. The throws are valid, not reliable. The throws are neither valid. Okay, so what you can see here is out of the 4 options, there's only one neither, right? Everything has like this valid thingy, but there's only one neither. So you can directly eliminate C. You don't need to even read anything because that's just there to throw you off. Next, let's look at A, B, and D now. The throws were precise but not accurate. Well, the object of this game was to hit the bull's eye. So if that was the object, if the object of the game was to hit the bullseye, that's what you want to look at. So the throws were precise but not accurate. The throws were valid but not reliable. And the throws were reliable but not precise. So hey, it's contradicting, right? Not precise, were precise. So it's like we have precise in the same sentence twice. We also have reliable here. So we can't cross out anything here. So this is where the teachers get you. But you got to think smartly. Well, you got to think about, in physics, there's 3 things, right? The reliability, accuracy, and validity. The throws are valid. Well, if all the 3 throws are correct, and the object was to hit the bullseye, well, you're obviously accurate. You're accurate because you achieve the thing, right? Reliability is achieving the same thing over and over again. So we're going to say the throws are valid, but not reliable. Or can we say throws are precise but not accurate? Well, a valid experiment is something else. So this would have to be A. And this is a very easy question. Nice. Okay, so now looking at this amplitude of the swing question, it's looking hard already. So we want to do some really hard educational guessing here. So here they say, as part of the investigation, students use a pendulum to indirectly measure the magnitude of the Earth's gravitational field at their location. Okay, interesting. Interesting observations. Nice use of formula. Now we want to look at this. Independent, dependent, controlled. What is similar so we could confidently strike out the others? Well, we see pendulum lengthwise. So that should be like an immediate hitter to you that, this is something. But then you can't just strike out A and B because you got to think logically. You see pendulum length twice here too. What else do you see though? Well, looks like this paper is specifically designed to eliminate, guessing. So we're going to strike out B and D. Okay, give up. No, I can't give up. So I'm just going to randomly guess, guys. I'm sorry. I'm not going to walk you through my thought process. So yeah, that's D. Which one are the Kepler's laws of the planetary motion? Well, Kepler, so it says all twice here, so it has to be that. We can, and then, this has the most info though. So this looks like it's right. Always, the more info you always choose, that's always right. Let's record these, right? It's A, D, A, D. What's the third one? Third one's also D. And your fourth one, the mass of Mars is approximately 0.1 times the mass of Earth, and its diameter is 0. That of Earth. Which choice gives the best estimate of the surface gravitational field on Mars compared to that of Earth as G? Well, we're talking about a lot of G's, but then just look at the numbers. There's a lot of 2's here, right? And then there's one 0.4. Like, what? Like, what are you doing, bro? You don't give it away that easily, right? That 0.4 is like obviously throwing you off. Then we continue reading through the question. There are two decimal points. See, these three, right, are decimals. But this value is a whole number. So it's obviously not going to be a whole number, not this. So it's left with these two. And here, it's where you got to use your brain. You got to read the question now after eliminating C and D. Like the mass of the Earth is 0.5. See how in the question that it's a two-letter thing? So the chances are it's going to be two letters too. So you go B. So this is question 4 and you go B. Ready? Now, question 5 is about circular motion, but I want you guys to keep reading this because I want to change the song that I'm listening to. Nice. So, everything starts with the objects. Now, they realize that students are guessing like this. So, we just look for similar terms. Okay? Constant speed, constant velocity, constant speed, constant velocity. So, we got to remove one note. Uniform circular motion. Motion, do they say it as speed or velocity? Well, I'm going to say this is physics, so it's going to be velocity. I know this argument is illogical, but you got to think outside the box when you're doing physics. This is as an ex-physics student myself. So, erasing A and C, we're left with B and D. So, the object has a constant velocity due to a magnitude force, direction perpendicular to its speed. Nice. I'm going to say it's B. Okay, and cool. And this is one of the tricky questions. Okay, obviously it's not going to be that, like what? Then, and then it's like less than, greater than. So it's not going to be a whole number, right? Because look at this. This is a text. It's not going to be a text. Only text out of 4 options. Highly unlikely, bro. Then, look here. This less than, greater than. So it's like a range. So it's probably the range because this is a specific value. Not that too. Then we're going to make an educated guess. See, it moves into a vacuum. So a vacuum and it's curving inwards. So it's coming down. So if this is 0 and that's like, going up like an axis, this is 0 and goes up to infinity on the x-axis. Well, that obviously makes sense. So we're going to say it's less than because it's coming down. This motion's down. So that is the brainwave and the thought logic. Beyond attempting questions like this, and I think this is a really powerful way to think, just generally even about questions. Okay, nice. Now, let me find something. Okay, nice. So, my bad for keeping you guys waiting. But yeah. Now, let's look at question 7. Now, it's a weird graph, but the alternative predicts the graph details likely to change different materials. So, we don't even need to read the questions. This is how you guess first. You just look at the question and you eliminate the options and then you read the question. This is a genius strat to solving any HSC problems in physics. Experienced, and the marks will speak for itself. So look, the slope of the line, well, is it the slope of the line? Well, look, slope of the line is no, right? So it's probably not going to be this. Like, why is there 3 no's? It's probably not going to be, okay, the chances are it's just that one singular yes is a no, because there's so many no's. It has to be the no. Okay, now we continue reading. Yes, no, it's not going to be that no. And then yes, no, yes. Well, it's not obviously not going to be that. So then we're left with this. No, yes, yes. And that is our answer, D. And these are just like some ways to think about these questions, right? There are many ways to approaching these questions, but this is just something that I would recommend in all situations. This level of genius thinking. Now let's look at this question. It's a split ring commutator question, my favorites, and it's like two split rings, and then they're rotating it, creating a magnetic field. General theory based questions. Which of the following best describes the motion of the coil when the switch is closed? Okay, cool. The switch is closed. Which of the best describes the motion of the coil? Well, if the switch is closed, it's obviously going to remain stationary. But we got to read. This is a DC motor. Okay. If the switch is closed, my bad. That's if the switch is open, no current is flowing. If the switch is closed, then the current is flowing through logical sense, right? So this is powering supply, and it's going to rotate. So obviously remove A. I don't know why I'm using logic, but oh well. And then the coil will rotate in one direction X, as shown in the diagram. Or the coil will rotate in the direction Y, as shown. Well, okay, it's obviously not D, because if there's two options that sound similar, and then this is just one that's absurdly different, no. And alternatively, no, that just doesn't sound good. It's not D. So these two are the tricky options. Tricky as in similar. Always cut down the distant options and then narrow it down to the options that look similar. That's my pro tip for any multis, really. So a coin will rotate in the direction X as shown in the diagram, and now we have to make a logical choice, right? Initially I had chances 1 in 4 of getting the question right. Now it's 1/2. Great odds. It's like, okay, so the coin will flip in the direction X. Well, let's see. Let's say it goes from the positive like this. So when you turn this on, north pole, it goes from north to south, the magnetic field lines. So using the right hand palm rule, thumb in the direction of the magnetic field, and then your hand in the direction of the current, and you see that it rotates in the direction of Y. Cool. See, right? Well, that's like the only question I've used my physics knowledge, guys. So don't get like annoyed or anything. But yeah, physics multis. Sometimes you need to know a little bit. But this is me. Like I haven't done physics for a term, right? AC DC generators. These are again very very simple, straightforward questions, right? It's like it doesn't get easier than this. What they ask you. What current will flow through the load resistor? This is some serious guessing and checking. And look, as I told you, use my strategy. Spot out the big ones, or spot out the weird ones that are different. Spot out the ones that are not in place, that do not belong. Okay? 5, obviously from our teaching, does not belong. Cool. Then, look for the units of the question. Are we given any units? Well, these are like, yeah, volts, ohms, turns. They're not looking helpful. So what will the current flow through the load resistor? Where is the load resistor? Well, I can't find it. But what's the current that's going to flow? So here we have to make another educated guess. And it all comes down to really educated guesses. So let's see. Okay, what I'm going to say is we're going to narrow it down to B and C. Because see how all of these start with 1, the ones place. And this starts with a 0. That's really off-putting. They're trying to pull you off there. Cool. So it's either B or C now. And then looking between B or C, you want to identify similarities. You don't ignore these A and D that you ignore. You take into consideration everything, right? So it's like, if I can put the tape, yeah. Tape, and then, yeah. So you don't want to rule out everything. But if you can... Exactly. Bruh. Nice. Here, you just want to look at this column. And what you realize here is it's never a 0, right? There's always a number. 8, but it's never a 0. So we can say to a better extent that it's going to be C, because the places kind of match rather than not. So for this question, we're going to guess it's C. Nice. Now let's do question 10. Now, question 10 is kind of interesting, and I've realized that this video has been going on for a while, so I'm going to speed this process up, because in the exam, you realistically, if you had this much time, you do yourself. So spot it quickly. Okay, you're like, okay, 0.8, 0.8, 12, 12. Okay, interesting. Then you're like, x to y, y to x, x to y, y to x. Okay, they've done a good job of balancing out the options. I have to give it to them. So here, because the question says 0.5, I'm going to say that I'm going to make a logical deduction so you can cancel out these whole number seconds. And it's going to be either A or B, right? And then, because, well, the induced EMF is, okay. We want to know if it's x to y or y to x. Alright, let's just keep it straightforward. X to y. Okay. We can see the coil. It goes like that. Because from y. Yeah, that doesn't really flow well. So it just goes from x to y. Okay. Plus, my logic was I haven't had any A's like in a long while. So it has to be A2. Alright. Now we're coming down to our final 10. Let's try and speed run these questions. Only one student, only two students, both students, student 1 through and 3. Okay, it's mostly never that, and this, not this 2. These are like 2 standalone options. So it's either this, A or B. And we got to make a reasonable deduction. Is it only student 1 or student 2? Then you look at this. The energy of the waves increase, 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 decrease. Well, I don't know why we have this odd decrease. So it's either student 1 or 2. Oh, that's what we already kind of eliminated already. Okay. Well, yeah, I don't know, guys. Hey, you're just going to have to randomly guess between that 50% choice. We're going to guess B. Oh, astronomer, cheating on hype. That's a whole funny scandal story. Anywho, let's get back to work. They're given it as in meters. The question's given the thing in meters, 150 meters. So, well, it's obviously not going to be 150 meters, but it's not going to be what the question gave you. But it has to be 3 digits. And we see that here, everything's 3 digits except for 1. So remove that. This is given in the question, so remove that. So now you're confident with a chance of 50% to either get it right. And you see that these are both half of each other, right? And if you... Which of the following is closest to the proper length of spaceship Y? Well, if you look at Y, it doesn't look that big. It doesn't look 900 meters big. So I must say C. 12 is 450. What to do here? Essential electrons measurement, maximum kinetic energy emitted. Okay. Well, see how these are 2 different options. Get rid of them. Here it's like similar, right? The reading. So it's either C or D again. So these are like, do these all the time, bro. Throw away the obvious one, like the ones that are different, throw it away. They're trying to trick you up between 2. Just pick those 2. Okay. Now the reading on the voltmeter, ammeter. See if they talk about the voltmeter, ammeter in these options. Well, they don't. Okay. So hey, the voltmeter, the current is in a minimum value. Ammeter, and the voltage is at a maximum value. Okay. Well, okay. Okay, so they're asking for the maximum kinetic energy. So I'm going to say it's going to be the minimum. So I'm going to say C. Nice. See, it's both here again. Okay, cool. Both of the options are both laser. Okay, but I must say this has to be not A nor B, because it says here both laser and incandescent. It has more words that are similar. It's trying to trick you. And because the question says compares incandescent. Well, wait. Sorry, I didn't read the question. It's a compare question, so it's not COD. Reading the answers, you see that they're wrong. It doesn't really compare, it's a similarities. And here, we see that incandescent lights are very wide, very narrow. So we're going to choose that here. I'm going to say they have a very narrow, because it says that. So SpaceX. Bruh, I really do like A. Like, I'm tired already. Which of the following a limitation of the Bohr model of atom? Well, Bohr, it cannot explain. So yeah, obviously get rid of the D. So it's A, B, C. It cannot explain for the observed Hawking value, hydrogen, atoms, electron. I'm just trying to see. Bohr model of the atom, right? Atom. So we cannot looking for the word atom, right? You're looking for the word atom, so you can get rid of D. C. It doesn't have the word atom at all. Now, observed line spectra of atoms with more than one electron. It cannot account. I'm gonna say it's A again. I know I'm pushing my luck this much. It's not good. It's not safe, but oh well. But at this point, 17 is also A. I'm not bothered to read 17. Feels right. The diagram, which transition emission photon with the most energy? Okay. Well, photon, electron, they're saying most energy, right? So most energy, obviously, is it the one that's the highest or the lowest? That's the real question we gotta ask ourselves. I'm gonna say that it's the most energy. So because you could say it's W, right? But that's too obvious. Like high max, that's the high value. That's the high maximum ceiling floor. And this is the minimum. If the question's asking about most energy, people would be like, oh, it's W. But see how all the other options are pointing down? So it's probably that. Get rid of that. But see how this one... Yeah, I'm going to say it's Y. So C. Below is a graph. Okay. A, B, C, or D. I'm going to say... We'll see. This is the longest one, so I'm going to say B again. No, it's B. Longest option. If I'm ever in doubt, I just choose whatever long option's big. Pre-Bogle. Bro, who the hell are you, Broglie? The diffraction interface observation of electrons. But this is genuinely tough because they're all different. You need to know this question, and that's why it's a question 20. And this is a band 6 differentiator in this subject. Everything else, students are just guessing like me. Trust me. In the HSC, students are guessing. They're not doing this. They're using this top tier methodology and just guessing the questions. So I'd say, hey, go with your luck. You have a 1 in 4, so 25% chance of getting it right. So be like, toss a coin, right? Let's analyze trends into it. Analyzing trends, we've got enough A's, tick. We've got enough B's, enough C's. Well, we've not got enough D's, so let's say it's the last one's D. Because, yeah, we're missing D. So, yeah, guys, that's my answer sheet to the 2023 paper. I don't have the answers because my friend sent me this, but do let me know in the comments whether I got them right. Let me know my score. I will also update you the score in the comments with the thing, but yeah, with until then, good luck. Wait, actually, wait a second. Let me find the